Hey 3B! In this video, I've got a book for you that I think you'll really enjoy. I'm reading from STEM in the Summer Olympics, The Science Behind Track and Field by Jenny Fretlin Van Voorst. Chapter 1, Race for Gold. Some track and field Olympians jump, others throw. That's a javelin there. These Olympians race over hurdles. Track and field is made up of many events. The best athletes use physics to go for gold. On your marks, get set, go. Many track and field events involve running. Olympic runners have to think about forces. Thrust is a force runners create. They use their muscles. It moves them forward. They want to be aerodynamic. Did you know? The marathon is the longest Olympic race. It is 42.195 kilometers long. That is more than the length of 384 football fields. Drag works against thrust. It happens as runners move. It is caused by the friction of air. They wear tight clothes. They keep their hair back. Why? Air can catch on these and create drag. Gravity is another force runners face, but Olympians use it to help. How? They lean forward slightly as they run. Gravity pulls them forward. They can move faster with less effort. Did you know? Who is the fastest person on Earth? As of 2019, sprinter Usain Bolt held the record. He ran 100 meters in 9.58 seconds. Will someone run faster at the next Olympics? Chapter 2, Jump High and Far. In some events, such as the high jump and the pole vault, athletes need to jump high. For others, such as the long and triple jump, they need to jump far. Behind all jumps is a law of motion. What is this law? Every action has an equal and opposite reaction. What does that mean? When you jump, you push off from the ground. This applies force to the ground. The ground returns your downward force with the same strength. What is the result? You spring up. If you push harder, you jump harder. Did you know? This law applies to running too. A sprinter pushes off from starting blocks. The blocks return the push in the direction the runner is going. Pole vaulters use science too. The vaulter runs. Kinetic energy builds up. This is the energy of motion. Greater speed creates greater kinetic energy. She jumps. The pole turns the kinetic energy into potential energy. This energy comes from location. More kinetic energy creates more potential energy. Take a look. What gives a pole vaulter kinetic and potential energy? Speed is the kinetic energy, and the height is the potential energy. Chapter 3, Wind Up and Throw. Shotput is a throwing event. These athletes throw a heavy ball. How far can they throw? Hammer throw is another. A ball on a wire is launched down the field. Some throwing events use a wind-up. In discus, the thrower spins around. His body twists. This builds up a force called torque. Torque provides extra power to the throw. The athlete stops moving. He releases the discus. All of his energy transfers to the object. Zoom! The discus sails into the air. Olympic stars use science to take home medals. How can you use science during your next field day? Thanks for listening along to the book, you guys. Bye!